Hello again, everybody. This week we're looking at cultural and linguistic considerations. It's a fascinating area and a really important one when we're thinking about inclusive education, particularly in Australian classrooms, because no matter where we teach, work, these will be really important factors. So as usual, I've got some warm-up questions for you. Take your chance to have a look at them and see how you'd go without going back to your notes first of all, but then of course go back to your notes and see how much you remember and what is still perhaps of interest for you to explore further. A couple of years ago, I asked Dr. Sue Cray, to make a video for my class because her field of expertise is in teaching students who are learning English as a second or other language. Now, these students are coming with the real gift of having another language with which to think and to be able to understand the world. And for those of us who are monolinguists, we've only got the opportunity to think in one language, and that can be quite a limitation. Unfortunately, in classrooms where English is the dominant language and lots of people in the room are monolinguists, they can sometimes have a way of thinking that it is somehow a deficit to not speak English as a first language. So Sue has a really helpful way of thinking about valuing multilingualism and then what you do to support learners. So there's a video that you can watch. I've loaded it into the learning materials for this week, and you can also have a look at the PDF of what are known as the band scales, which are a helpful way of giving a sense of where an English language learner is and where their development is proceeding. Mathematics is an interesting area because it was once thought to be the universal language, that we all used the same symbols and so we could communicate without any issues. There were also problems where we had learners being put inappropriately into different mathematics classes based on cultural decisions. So there was an assumption that certain groups would be automatically better at mathematics than others, and students who sometimes had language issues were placed in lower stream mathematics classrooms and subjects such as the humanities disciplines of mathematics, like mathematics applications or mathematics in society, and the language load of those was immense. So that was actually a problem. But if we think about mathematics being the universal language, we don't have to think about it for too long to realise that that can't be a concept that makes sense. The way we do mathematics is culturally based. Now, the pictures that I have there come from an Indigenous community where I was doing some work. And in this one, there were screen prints being made for a cultural event in the community. And one of the things that struck me was seeing the design and seeing the way the geometry was portrayed. Now, this is an area of mathematics that's been extensively studied in recent times, perhaps since about the 1950s on. One of the things that was noticed was that in many groups where there'd been a thought that mathematics wasn't terribly important, they actually had a lot of attention on areas of maths like geometry. Perhaps not as much of an interest or focus on arithmetic. And so the early views were that mathematics wasn't important. Nothing could be further from the truth. So with the study of geometry and a real understanding of patterning, we came to understand geometry a lot better. And a lot of the ideas that were evident in the geometry and the patterning in some of these cultural groups became fundamentally important in computer design. So in graphics and images and ways of transforming images was fundamentally about the transformation geometry, and we learn a lot about that through ethnomathematics. So a study of culturally based mathematics has led to really development of new areas of mathematics and valuing those. And so the field of ethnomathematics emerged. So maths is heavily loaded with language. Now here's a bit of an activity for you to think about. Think of the list of mathematics words that you've used today. So if you sit back and just make a list. How are you going with your list? So how did you go with your list? You can separate your list into words that are the same as in common usage, words that are different from common usage, and words that you'll find in mathematics alone. So let's have a look at the first column. Simple words like area and add we use in the same way in maths as we do in general usage. In the second column though, these are words where there are problems because the way we use them in general language is different in the maths classroom. So you can imagine the confusion. If we take the first one, a product. Product is in general usage something that might be in a shop catalogue. What products are for sale? Or we could think about it as something that is made in the course of doing an activity. What's the product that will come out from this? Whereas in mathematics, it means multiplication. So if I say, what's the product of 6 times 7? I'm supposed to know that that means to multiply, and the answer will be revealed as 42. So you can imagine that kids who don't understand what on earth we're talking about could come up with some difficult problems. Let's jump down to mean. If I'm talking about mean in common usage, I could be talking about they're mean to me, or what does that mean? In mathematics, we'd be thinking about perhaps an arithmetic mean, but there are other types of means. So we need to be very careful with our vocabulary and be careful about words that might be confusing. Then there are some words that you'll find in mathematics only. Hypotenuse, parallelogram, rhombus, they're words that are maths words. The difference between a diamond and a rhombus, a diamond is not a maths term because in general usage, a diamond is really a rhombus, so it's a square turned on its side, and we don't have orientation in geometry, but that's a bit specific. But the point is here that when we are teaching maths or really any other subject, we've got to be very careful about the vocabulary we use and make sure that everybody knows what those terms are. One of the really important things to do is recognise that there are other ways to learn our subjects of mathematics, and we need to value and appreciate other ways. I've already mentioned about the importance of appreciating geometry. I've mentioned the importance of recognising vocabulary can change. Here's some examples then about some of the challenges of our learners who come from cultures where we have different mathematics and we don't always appreciate it in the ways we assess it in aspects like NAPLAN. On the left-hand side, you'll see a picture of children playing on a huge hundreds chart. What the teachers recognised in this community with numbers were not very obvious. So they weren't used a lot at all. You couldn't see them. There weren't house numbers. There weren't numbers just generally seen. So they decided that they would paint hundreds charts, and their children did a lot of physical activities. So stand on a number, now add on 10, and then they realise that they have to step back and go down the hundreds chart. All sorts of fun games, and the teacher said they saw the kids coming in on weekends to play on these great big 100 squares. So that's fabulous. That was a way of helping them to understand and get familiar with numbers. The other issue that there is a sense that, okay, numbers mightn't be so common, but when we've got geometry is not measured terribly well in our culture, as in the Western culture that sets the maths curriculum and has NAPLAN, because we do geometry in a bit of a different way. If you're living in an area where you go out hunting kangaroos and you've got to find your way back to camp, you've got to know how to find your way through probably what my eyes would say would be a pretty hard to navigate through environment. And there are all sorts of impressive accounts of even toddlers being able to tell where their direction is to on a compass scale, to not just north, south, east, west, but many different ways of knowing exactly where to look. Because we don't really know how to teach it or measure it, it doesn't emerge in NAPLAN results, which is a bit of a shame. On the right-hand side, this is a class that's in Central Australia. It's outside Alice Springs. And these children all come to school speaking Aranda. They have an intact Indigenous language that they learn as their first language. And these two ladies in the classroom are Indigenous teacher aides, and they are bilingual. They speak Aranda and English, and they support these children to help them to learn. In the initial years, they learn mostly in Aranda and gradually learn English as they go. And they're learning in this particular clip, they're learning how to do a lesson on counting. And I'll just see that in this, I'm going to try to get a clip going here. Bear with me. The point is that these children are speaking Aranda, and every so often you'll hear some words that are spoken in English, and they're the maths words. Now, these children do their NAPLAN in year 3. In that year, they're just starting to learn to read and write in English. They've been learning as they go, as I said, in Aranda and English, and they're really just starting in year 3 to come to read in English. And when they do their NAPLAN, it's written in English. And I asked, well, can they translate it? And they said, well, yes, that's perfectly acceptable. They can have it translated and they can have it read to them. But they had some troubles trying to translate some of the concepts. One of them was a prism, which is a 3D shape, and it's a solid and it's enclosed. And there is not a word that is adequate to translate that concept, because in Aranda they're desert people, so they don't live in enclosed spaces, and they didn't have a word for it. Now, there are other concepts in their way of seeing mathematics that don't translate well into English, but that's not an issue because we don't have to test in Aranda. Now, these children tend to do poorly on NAPLAN, but it's not an indication, in my view, that they're actually poor at mathematics. And it's one of the big challenges that we have in trying to understand what do learners know, what do they need to know, and how do we then go about measuring that. So I've been talking about mathematics as an example. The context of learning is one of those features. We know it doesn't matter what you're learning, but it does matter about what the context is. And Jean Lave and Etienne Wenger were probably the first who were really exploring the contextual basis of learning, and they wrote about situated cognition. These things are important for us to consider, and when we consider the context that learners are in and what they're learning, we need to then think about what are the impacts, particularly across Australia when we are trying to measure those things and compare nationally. It's my view that we should not be considering this from a deficit perspective, but what we should be doing is trying to work out what we can do to think about from what do these learners bring to their classrooms. And it's not to say that NAPLAN doesn't give us some important measures, because it does show when kids are not learning, where they're going backwards or where they're just learning the same material over and over again. So when I was talking earlier on about what that teacher had done in Wadia, she was recognising that there was a problem and it could be fixed. So we can't just ignore it, and we can't just say and use it as an excuse. We've really got to be thinking about what the issues are. And some of those issues can be flooding. As you can see, that the school's inundated and it doesn't open then for months at a time. We can be thinking about the vast distances between anywhere where teachers can get professional learning. And then we can think about learners themselves in those contexts. This is another issue. Some of our curriculum materials are really culturally biased. So in curricula such as the social studies curricula, the maths curricula, where they talk about the seasons and the 4 seasons as though that's the same the world over. Well, we live on a globe. We live on a sphere, and the position of the sun actually matters. And unless you're in the temperate zones, you don't have those 4 seasons. And so the Tiwi calendar, the Tiwi Islands are up off Darwin. And so they're in very much equatorial areas. They have not just wet and dry, as we sometimes hear it said. I was struck when I was there by this calendar. Take some time to have a look at it and explore all the different things that happen. And you can see perhaps the sector up in the top left, where you've got December, January, February, March. Now we know that that would be the cyclone season, and I just love that picture of the mother holding on to the little child who's been blown off their feet. It's a delightful picture. And so this one talks about what's happening in the weather, what fruits are available, what animals are available, and it's a calendar that really gives a very interesting perspective. So our curriculum itself can be culturally biased. Now, on the study guides, I've got some handouts where you can read more about some of the Indigenous mathematics that's been recorded. And, you know, if maths isn't your area, you might be thinking, well, that's not really much interest, or why is, you know, it's not really relevant to me. But I'd like you to think about it as an example for a context, and maybe you could explore and find some other areas more relevant to your own teaching area, if that would be appropriate. But I think because mathematics is one of those areas where it's so often seen as a deficit for our Indigenous learners, that it's a really powerful message, certainly it was for me, to really understand how we weren't valuing what these learners were bringing to their classrooms, really because we didn't know what we were looking at. So I found it helpful. Maybe it will be for you as well. So some issues to consider. See the reading guide for this week. There are quite a few ideas there that you can read and explore. What we were looking at is multilingualism as one of the things, so you can watch the video from Sue Cray. There's Indigenous ways of knowing, and I've really talked about that as a sense in terms of mathematics. And one of the things that you'll find in the readings is about thinking about being deaf as a cultural group. So I think you'll find some of those readings very interesting. I hope you do, and look forward to hearing from you maybe on the discussion board where we can continue the conversation.